So welcome everybody to this latest video on 162 Maths, and in this video we're going over a quick topic test with a collection of some GCSE exam style questions on properties of polygons at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now before we get started working through this test paper, there is no indication about whether these questions refer to a calculator or a non-calculator paper. So what we'll do is we'll just make sure that we show our full working out and assume that it's non-calculator, so that if they do appear on a calculator paper, it should be moderately easy compared to how much working out we need to do. So looking at question 1, it says work out the value of x. So again, you can see that we've got a quadrilateral, and we should know that all angles inside a quadrilateral should add up to 360. So here I've got x plus 156 plus 69 plus 47 should all add up to 360. So if I add up those three numbers, I've got an equal sign there, stick a plus. And if I add up those three numbers, I should have an answer of 272 equals 360. So x equals 360 minus 272, and that should give you an answer of 88. Now, this question may seem a bit dodgy, and the reason for that is because our answer is an acute angle, where on the diagram it shows that x is an obtuse angle. However, the key thing to note, and I think this is particularly a rarity of this, usually in an exam, if a diagram shows an acute angle, you should end up with an acute answer. If it's an obtuse angle, then it should give you an obtuse angle. So again, it's worth noting, but again, as long as you check your working out and you can see you've done nothing wrong and you double check your answer, if it's all you get twice or three times, then it should be correct. It then says give your reason for your answer. Well, the total sum of angles inside a quadrilateral or four-sided shape add up to 360 degrees. Moving on to question 2, it says tick the correct statements. So the first statement is that a regular polygon has every side the same length, and that is true. It then says a regular polygon has every interior angle of the same size, and that is going to be true. It then says an irregular polygon doesn't have equal sides, and that is true. And it says that the interior angle of a regular polygon is found by dividing 360 degrees by the number of sides, and that is false. That describes an exterior angle, not an interior angle. The next question then says write down the sum of angles inside a triangle, and that should be relatively easy, as being 180. Moving on to question 4, it says that the interior angle can be calculated by doing 180, divide 180 multiplied by n minus 2 divided by n, where n is the number of sides of the regular polygon. So it says use the formula to find the size of one interior angle with 8 sides. So this is where n equals 8. So what I need to do is I need to substitute 8 into this formula. So here I've got 180 multiplied by 8 minus 2 all divided by 8. So that's going to be 180 times 6 divided by 8. And then from this, I can just work that out. So I can do 180 times 6 divided by 8 in any way you want. And that should give you an answer of 135. Another way of doing it is just by simply cancelling things down. So for example, I can divide everything, two things by 2. So that's going to be, let's have a look. We can divide both numbers by 4. So that's going to be 45, and that's going to be 2. So I can do 45 times 6 divided by 2. I can then divide that by 3 and that by 1. So 45 times 3 gives me 135. And again, several ways in which you can do it if you don't have access to a calculator, or if that question was on a non-calculator paper. Question 5a then says draw a trapezium in the space below. Mark on any important features. Now there's several trapeziums you can draw. So I can draw one that looks like a roof, in which the key things you need to note is that these two sides are going to be parallel. So the two bases of what you'd class as A and B are going to be parallel. And you could also have something that looks like this. And there are your two parallel sides. If you have done an isosceles trapezium. You could have like two parallel sides there, but it's not essential. As long as you've drawn little arrows just to find that they're two parallel sides. But it does say mark, so even if you just draw a trapezium, that doesn't quite look, but you can say that this in this are parallel, then that should also be fine. But I would probably opt for either this or this by using the arrows to define which two sides are going to be parallel. For B, it then says, describe the important feature of a kite. You might draw a diagram to help you, but you must clearly identify and explain the features. So let me just quickly draw a kite. So with the kite, we've got two sides that are equal. So those two sides are going to be equal. We know that this angle here is going to be the same as this angle here. And we know that the diagonals, meet are perpendicular or meet at 90 degrees. So any of those two statements would be true. So let's put for sides of a kite, we've got the two adjacent sides are equal. You can also say that you've got two pairs of equal sides in terms of length. And that's pretty much it, I would say, in terms of the sides of a kite. Then in terms of the angles of a kite, we can say that you've got two pairs, well, two angles are the same. So two angles are equal. You've got that the diagonals meet at 90 degrees or are perpendicular. So anything along those lines would be absolutely fine to get the 2 marks.